Now to determine the SI units, the constant chi is now fixed by the first equation, and kappa, alpha, beta, and AT are related by the second and third equations, which gives us the last equation where the speed of light squared equals alpha over eta beta. So we're going to use the charge conservation where the continuity equation is satisfied. We need to take the divergence of the two top equations that we determined from the two polar vectors that we could use under time reversal that we could use for these. And when we took the divergence of them and putting them together, we have the continuity equation, which is the partial derivative of rho with respect to time plus the divergence of the current density equals 0. For this to be true, chi alpha has to equal negative beta. To find eta, they use the Lorentz invariance of the Lorentz force for small velocities where velocity is much less than the speed of light, and is sufficient to consider the Gaussian transformation given on the equation on the board, where r goes to r prime, which equals r minus v naught t, where v prime equals v minus v naught. This leads us to the first equation where they determined the identity of the vector and the scalar character of the quantities appearing in the Lorentz force with their behavior under the reversal of time, where we replace v with v naught plus v prime from the Gaussian transformation, and our ending results is the charge quantity of the electronic field prime plus eta times the velocity prime crossed with the magnetic field prime. For the fields, the postulated invariance of the Lorentz force means that E prime equals E plus AT times velocity naught crossed with B, the magnetic field, where the B prime is equal to V. I'm not going to go, the next calculation, I am not going to go through the whole thing, but they basically do the same thing with the first equation that I just showed you, with the equation we found for generating the Maxwell equations when we found the divergence of the electric field. So when they take the divergence of the electric field, equaling it to the divergence of the electric field through a Gaussian transformation, they end up with the following. E prime equals E plus chi v naught crossed with the magnetic field, which looks very similar to what we found a couple equations ago, where E prime equals E plus eta times v naught prime crossed with the magnetic field. So here we can conclude that chi equals eta from the invariance of the Lorentz force. Then we have the wave equation, where we want to take the vanishing inhomogeneous charge density rho and the current density J by taking the curl of the first equation here that we determined from generating Maxwell's equations in the last section. And when we do this, we're left with del times the quantity of the divergence of the electronic field minus the change in the electronic field. Then this leads us with the gradient times the divergence of the electronic field minus the change in the electronic field plus chi multiplied by the gradient crossed with the partial derivative of the magnetic field, which this then gives us the negative change in the electronic field minus chi gamma with the electronic field, which gives us 0. For this to remain true, AT times kappa equals -1 over the speed of light squared. So when they have the remaining constants with the held velocity c, determined by measuring the velocity of electromagnetic waves in a vacuum, which turns out to be 2.99.86 times 10 to the 8th meters per second, which is the universal vacuum of speed of light, it is worthwhile to note that the velocity with the same numerical value can be determined by pure electrostatic and magnetic measurements. Two of the constants can be chosen arbitrarily, and we're going to use where eta equals 1, kappa equals -1 over the speed of light squared, or beta equals 4 pi times 10 to the -7 newtons over ampere squared, which is the magnetic constant, U naught. Then alpha equals U naught c squared, which is equivalent to 1 over epsilon naught, which is the permittivity of free space. And then the Lorentz force is given by that following equation, where the Lorentz force equals the Q of the quantity, the electric field with respect to R and T, plus the velocity crossed with the magnetic field of R and T. And here are the Maxwell equations. The gradient crossed with the electric field equals the negative derivative of the magnetic field. The gradient crossed with the magnetic field equals the U naught of the current density with respect to R and T plus U naught epsilon naught multiplied by the first derivative of the electric field. Then we have the gradient dotted with the electric field, giving us the charge density with respect to R and T over epsilon naught. And then last but not least, the gradient dotted with the magnetic field equals 0. In conclusion, they started with the Lorentz force as an experimental fact, using simplicity and linearity that Maxwell's equations for the electromagnetic fields gives us two axial scalar equations for the divergence of the electric and magnetic fields and two axial vector equations for the curl of the electric and magnetic fields. The vector characters of the fields and their transformation properties under time reversal is how they mainly approached obtaining the Maxwell equations, as well as charge conservation, the Galileo invariance of Lorentz force, in that electromagnetic waves propagate the speed of light allowed them to fix 3 of the 5 undetermined constants in the Lorentz force equation, and then the 4 deduced Maxwell equations. Thank you, and I hope you enjoyed my video.